Let's work another problem involving solutions and solution concentration. Sometimes students in this class, I think, look at, oh, K2CR207, I can't do anything with that. Well, yes, you can. You know, take your time, read the problem, and kind of think about what you know about it. So it says that they already prepared this solution. This is actually K, of course, stands for potassium. It's K2CR207. Do you remember the name of that polyatomic ion is dichromate? So this is potassium dichromate. And it went like this. Potassium is a +1 ion. CR207 is a -2 polyatomic anion. So it crisscrossed, and voila, that's how you got this formula. Anyway, so that's the solute, and notice it gave us the molarity. Here in the next slide, I'm going to actually unpack that. And let's just see what we're after, though. It says an experiment calls for 0.015 moles of K2CR207. So actually, I'm going to put that 0.015 moles. And there's only one thing here, so I don't have to be explicit about that. Moles of solute, moles of K2CR207. How many milliliters? So that's my question over here. Question mark milliliters of solution do I need to measure out to get this moles of K2CR207? So, well, let me just go ahead and unpack it now. Remember that we know that anytime you see this M, that means molar. So what that M means is, for this particular solution, there are 0.255 moles of K2CR207 in 1 liter of solution. So do you see how actually I can use this, which is the definition of 0.255 molar, right there, to go from moles of solute to what? Liters of solution. Very good. And then how do I get from liters of solution to milliliters of solution? Yep. 1 liter is exactly equal to 1,000 milliliters. Exactly. Kind of got ahead of myself, but that's how we're going to work this problem. So you should never work a problem and leave the big M unpacked. Sorry, packed up. You should never leave it packed up. You should always unpack it. What does big M mean? It means moles of solute, in this case K2CR207 per 1 liter of solution. We could also flip it over if we need to. In 1 liter of solution, it will contain 0.255 moles of K2CR207. We can also write it flat like this. So the strategy looks like this, where, like I said, we're going to use molarity to go from moles that we're after to liters of solution. And then in this particular problem, we have to kind of fix our liters to milliliters using something we've used before. Within the metric system, 1 liter is exactly equal to 1,000 milliliters. So the first term is the thing we want to convert. So what does that second term look like to have moles cancel, be left with liters? It looks like this, which is kind of what I call the flipped version of molarity. Does that make sense? So this is your molarity. And in this sense, units of moles cancel, we're left with units of liters. Now what does the last term look like? To have liters cancel, be left with milliliters. Yep, it looks like this. Where doing this with units of liters on the bottom will cancel, we'll be left with units of milliliters. Very good. Okay, how many sig figs do we need to allow in our answer? Only 2, because there's uncertainty here. This is a placeholder, so it's not significant. This is significant, so we have 2 sig figs here. There's uncertainty brought here, but I'm liking 3 for that. And there's no uncertainty brought here. So we're conservative, so we're only allowed 2 sig figs in our answer. So 59 milliliters of solution is the answer. Let's work one more problem. So in this case, we're dealing with a solute of calcium chloride. And let's see, how many moles? So that's going to go over here on the right. So question mark moles are there in 75.0 milliliters of solution. You're like, I have no idea. Well, notice that it gave us the molarity. So actually, if we can get from milliliters of solution to liters of solution, which we totally can, right? We can get from liters of solution to moles using this molarity. And again, I have a slide coming up to unpack that. Let's just go ahead and say the flat version. What the big M means is that for this solution, there's 0.108 moles of calcium chloride, Cl2, is equal to 1 liter of solution. So if we use this right here, we can get from liters of solution to moles. Okay. I guess I didn't unpack it. So like I said before, we can't use molarity with milliliters because molarity is moles of solute per liter of solution, not milliliters of solution. So we have to get from milliliters to liters using, like I said, this relationship within the metric system. And then once we're to liters, we can use molarity then to get from liters to moles. Not too bad. So what's our first term going to be? It's going to be the thing we want to convert, 75.0 milliliters of solution over 1. Don't forget over 1. So we want milliliters of solution to cancel. What does our next term look like? It will look like this. 1 liter of solution over 1,000 milliliters. Very good. Milliliters of solution cancel. We're left with liters of solution. Now we're going to use molarity. And what does that look like? It looks like this. 0.108 moles of calcium chloride over 1 liter of solution. It's the non-flipped version of what I call molarity. In this case, liter of solutions cancel. Milliliters of solutions had canceled before. Left with units of moles of calcium chloride, which is exactly what we want to be left with. Now, how many sig figs are we going to round this to? We're going to round it to 3 sig figs. 1, 2, 3. Remember this? It's all about the zeros. That's what we call a trailing zero after the decimal. So it counts as significant. No uncertainty brought here. And we also have 3 sig figs here. So we're allowed 3 sig figs in our answer. Did you get this? So now 3 sig figs. Remember, this is a placeholder, significant, significant, and to show a third significant zero, we need to do a trailing zero after the decimal. Okay. Very good.